Picture yourself listening to the sound of a black hole, a cosmic phenomenon that has captivated scientists and stargazers alike for decades. Imagine the noise of a billion stars collapsing into a singularity, or the stretching of spacetime to its breaking point. It's hard to fathom, isn't it? But what if I told you, NASA has made it possible to hear the sound of a black hole for the first time in history? Join us as we unveil the groundbreaking technology and research behind this historic achievement. Don't miss out on this and other fascinating space-related videos like this one. Please subscribe and press the bell icon now. Black holes, mysterious and powerful objects in the universe, have captivated scientists and stargazers alike for decades. These incredibly dense regions in space are formed when massive stars die and their cores collapse under their own gravity. The intense gravity of a black hole creates ripples in spacetime, known as gravitational waves. For decades, scientists have theorized about the existence of these waves and the possibility of detecting them. But it wasn't until recently that NASA made a groundbreaking discovery: the ability to record the sound of a black hole. Today, we're going to take a closer look at this historic achievement, from the technology behind it to the research and international cooperation that made it possible. We'll explore the process of converting gravitational waves into sound waves, and we'll hear the sound of a black hole for the first time. We'll also discuss the future implications of this breakthrough and its potential impact on our understanding of black holes and the universe as a whole. So, sit back, relax and get ready to hear the unheard. Extreme objects like black holes can be found throughout the universe. Supergravity zones are regions of space with such a high gravity that not even light can leave them. The intense gravity of a black hole creates an event horizon, a point of no return beyond which anything that enters is trapped forever. The center of a black hole is called the singularity, where the laws of physics as we know them break down. Black holes are formed when massive stars die and their cores collapse under their own gravity. When the fuel at the core of a massive star is exhausted, the star's outer layers collapse inward, crushing the core. If the core is massive enough, it collapses to a point of zero size and infinite density, forming a black hole. Black holes come in different sizes, from small ones that are only a few miles across to supermassive black holes that are billions of times more massive than the Sun. Scientists believe that supermassive black holes reside at the center of most galaxies, including our own Milky Way. Black holes are incredibly difficult to study because they don't emit any light and they are invisible. But scientists have been able to detect them through their effects on nearby matter and by observing their powerful gravitational pull. And now, thanks to NASA's recent breakthrough, we can also hear the sound of a black hole. Gravitational waves are distortions in the spacetime continuum generated by the rapid acceleration of very massive objects, such as black holes. These waves travel at the speed of light and are incredibly faint, making them difficult to detect. But when they pass through matter, they cause tiny distortions, much like the ripples caused by a stone thrown into a pond. Scientists have been searching for these waves for decades, and in 2015, the Laser Interferometer Gravitational Wave Observatory, LIGO, made the first direct detection of gravitational waves. The discovery was a major breakthrough in physics and astronomy, and it opened up a new way of observing the universe. Gravitational waves are created when two massive objects, such as black holes or neutron stars, orbit each other and emit energy in the form of waves. The more massive and closer the objects are, the stronger the waves they produce. Black holes are some of the most powerful emitters of gravitational waves, and they are also the most difficult to detect. The LIGO and Virgo detectors are able to detect these waves and convert them into sound waves, allowing us to hear the sound of a black hole. This breakthrough has given scientists a new way to study black holes and has opened the door to new discoveries and insights into the universe. The Laser Interferometer Gravitational Wave Observatory, LIGO, and the Virgo detector in Italy are the two main instruments used to detect gravitational waves. These detectors are incredibly sensitive and are able to detect incredibly faint ripples in spacetime caused by black holes and other massive objects. The LIGO detector consists of two 4-kilometer-long arms arranged in an L shape. At the end of each arm, a laser beam is split and sent down each arm. The beams are then reflected back and brought together again. If a gravitational wave passes through the detector, it causes a tiny distortion in the distance between the ends of the arms, which is detected by the laser beams. The Virgo detector works on a similar principle, but it uses a different type of laser and a different shape for the arms. Both detectors are incredibly precise and are able to detect distortions as small as a billionth of a meter. Together, the LIGO and Virgo detectors provide a powerful tool for studying gravitational waves and black holes. They allow scientists to observe the universe in a completely new way and to make new discoveries and insights into the nature of black holes and the universe. Converting gravitational waves into sound waves is a complex process that requires sophisticated technology and advanced mathematical algorithms. The LIGO and Virgo detectors detect the faint ripples in spacetime caused by gravitational waves and record the data. This data is then processed using mathematical algorithms that convert the waveforms into sound waves. The sound of a black hole is not what you would expect. It's not the roar of a massive object, but a faint chirp, similar to the sound of a bird. The pitch of the sound depends on the frequency of the gravitational wave and the mass of the black hole. The higher the frequency and the larger the mass, the higher the pitch. Recording the sound of a black hole is a monumental achievement, but it also comes with a number of challenges and limitations. The main challenge is the faintness of the signals. The gravitational waves are incredibly faint and are easily drowned out by noise. To overcome this, the detectors must be isolated from all sources of noise, such as seismic activity, and the data must be carefully filtered to remove any noise. Another limitation is the distance of the black holes. The farther away the black hole, the weaker the signal. This means that the sound of a black hole is faint and difficult to hear. Scientists are currently working on developing new technologies and techniques to detect and record the sound of more distant black holes. Despite the challenges, recording the sound of a black hole is a major breakthrough, and it has opened up a new way of studying black holes and the universe. Recording the sound of a black hole is a significant achievement that has the potential to revolutionize our understanding of black holes and the universe. It provides a new way to study these mysterious objects and allows scientists to test theories and make new discoveries. For example, by studying the sound of a black hole, scientists can learn more about its properties, such as its mass and spin, and how it interacts with its surroundings. The future looks bright for gravitational wave research. The LIGO and Virgo detectors have been upgraded and are now even more sensitive than before, and new detectors are being developed, such as the space-based LISA detector, which will be able to detect gravitational waves from even farther away. These new detectors will allow scientists to study black holes and other massive objects in greater detail and to make new discoveries. International cooperation has been vital to the success of gravitational wave research. The LIGO and Virgo detectors are the result of a collaboration between scientists from around the world. This collaboration has brought together the best minds in the field and has enabled the development of sophisticated technologies and techniques. Private companies have also played an important role in advancing our understanding of black holes. Companies like LIGO Laboratory have invested in the development of advanced technologies and have provided funding for research and development. This has been instrumental in the success of gravitational wave research and has opened the door to new discoveries and insights into the universe. In conclusion, NASA's recent breakthrough in recording the sound of a black hole is a groundbreaking achievement that has the potential to revolutionize our understanding of these mysterious objects. We've learned that black holes are incredibly dense regions in space where gravity is so strong that nothing, not even light, can escape. We've also learned that gravitational waves are ripples in the fabric of spacetime caused by the acceleration of massive objects, such as black holes. And thanks to the Laser Interferometer Gravitational Wave Observatory, LIGO and the Virgo detector, we are able to convert these waves into sound waves, allowing us to hear the sound of a black hole. We've also seen how international cooperation and private companies have played a vital role in this achievement. With the help of LIGO and Virgo, scientists are able to detect gravitational waves and make new discoveries that can change the way we think about the universe. It's a groundbreaking achievement, and it's just the beginning. With the upgraded LIGO and Virgo detectors and new detectors on the way, we can expect even more groundbreaking discoveries in the future. Thank you for watching this video. If you like this video, please subscribe to our channel and hit the bell icon, and leave your opinion in the comments section. We would love to hear your thoughts.